Let's figure out how to prepare for a physics exam. And it's kind of like doing some theoretical research. Um, After a lot of failed attempts, I've fine-tuned my approach for studying for physics exams. So we'll cover preparation methods, practice questions, and what to do when you're completely stuck. So a lot of the times, if you're looking at a really hard problem, you can't really see the shortcut to finish. Notice that guy just kind of took off and went to the shortcut. This guy is going along the long way, and you can't see the shortcut. So we're seeing a problem, and boom, we missed the shortcut. So this is a common issue when you're trying to solve physics problems. Also, the fact that there's so much information to remember that it's kind of impossible. Like you're gonna need so many notes, so many different papers, so many equations. Uh, it's kind of impossible to remember everything in math without some kind of a cheat sheet, usually. And of course, a lot of times we don't really have an exam rehearsal strategy. So, this guy, he's practicing for his guitar. He knows what to do. He's got a little strategy to practice. But this isn't really common for physics students. We don't really have like a strategy or a method that we use to practice exams. So let's talk about exam prep strategies. The first thing you want to do is always do homework and go to lectures and stuff, and you might get notes, you might get assignments, all sorts of things. And you want to do them, you want to sort of get by with them and sort of fill them out and do all that stuff. But then you want to put all the information you've learned into your notes. So your one page of notes is the key, putting all the stuff that you've learned from your assignments, from your homework, from your classworks, from your textbooks, everything gets put into one piece of notes here. So you can see the connection between all the different topics. And once you have your notes, uh, this is basically the key to everything. Um, your page of condensed notes is the key for any subject. And if you start writing an entire book of notes, the information, the presentation, first of all, the information can be too much. And the presentation might be nice if you make a nice little book. Like a book is nice presentation, okay? But it's not extremely effective because you're gonna have to like search through the whole book to find a little piece of information. If you have everything on one page, you can immediately see the info like with your eyes just right there. You don't have to turn any pages. You just look onto another piece of the paper and maybe flip it over if it's really a lot of information. You don't want to write small. But the idea is you're going to be able to see connections between seemingly unrelated topics. So that's the key to having one single page of notes. Really important. Uh, Now, once you've got your notes and all that stuff, you're going to want to start essentially generating or finding multiple choice questions that are related to your notes, related to all that stuff that's on a piece of paper that you've just created. So you might even give it to, the AI or some ChatGPT to be able to just generate some multiple choice questions. You want to say, give me some multiple choice questions, maybe conceptual to start with, maybe mathematical later. But here's a question. I haven't given the multiple choices yet, um, but the idea is you want to give the multiple choice and you also want the solutions. So question, the choices, and the solution. Start with this question here. It says the nucleus of uranium-238 spontaneously decays, releasing the helium nucleus in the process. Which statement is true? We have to figure out like how to answer this question without looking at the answers. Um, if you know anything about the nuclear physics, you might have the equation. You might kind of already realize that a helium nucleus is should be like a 4 and a 2 in terms of these numbers, 4 and a 2. So when you add that, or when you since it's a decay process, you're going to subtract it. So when you subtract that, you should get 234 and 90. So that would sort of be your answer, and let's see if that is part of the answers. It looks like it's this one. So if I am somewhat correct. Oh, but there's two answers here. Alpha decay or beta decay. We have to kind of know. So notice that at first I gave the answer to the question without even trying, like without looking at the solutions. And now we're looking at the options. And we realize there's two types of decays. So we're going to identify it as beta decay. Or no, we're not. A helium nucleus should be alpha decay. So I'm gonna guess that it's D because the alpha particle is like a helium nucleus is an alpha particle, a 4-2. So I'm pretty sure it's D. Now, this is just what my thoughts are, but let's just see what the solution is. As you can see, we sort of took a three-step process. First, try to figure it out without the answer. You get something close, and then you look at the solutions. Okay, maybe now you probably have the answer right. And now look at the solution. So it says write the equation out just like this, like I was explaining. And you can either subtract 4-2 from here or uh, add to here because obviously it's a decay process. But anyway, so yeah, this is exactly the explanation that I was saying. And it's an alpha particle, this 4-2 thing. So that's just something you just kind of have to know that this is an alpha particle, not a beta particle. Beta decay, it's more to deal with like neutrons getting lost and placed by protons or something. So anyway, here's how we want to approach, one example of a good quiz question, multiple choice question. Figure it out without looking at the solutions, without looking at the options, then pick one of the options, and then look at the solutions. Okay, uh, so here we have the exam prep strategy again. We're looking at the homework, the lectures, the notes that we come up with, and the multiple choice that are derived from the notes. This is all sort of derived from each other. So you get the homework, and then the notes are derived from all that stuff, and then the multiple choice is derived from the notes. Once you've figured out these multiple choice questions, you can always like plug them into a Quizlet or make flashcards for them to sort of repeat them if you want to. Um, but now let's consider difficult questions. So difficult questions are important. You want to base all your practice questions around your assignments, of course, but you want to get slightly harder questions than what you're given. So, but of course, it's really easy to get out of scope with this process because it's really fun to like do really, really hard problems. But you want all the things that you're learning with these difficult questions to be able to put them back onto your notes. Okay, it's a feedback process. You're gonna take the notes, make questions from them, and then the questions that you're gonna find some new things, so add those to the note page. It's a feedback, back and forth, questions the notes, the questions the notes, so they kind of enhance each other. But the problem is if you start doing like Lagrangian dynamics when you're studying optics, that's it's probably out of scope. So you want to do stuff that's like still within that same page of notes, and putting it on one page helps to make sure that everything on that page is related and doesn't go too far off tangents and get you out of scope. Because it's pretty easy to go out of scope. But let's see these difficult questions that we're solving. These are probably going to be more like math questions at this point. So you could do conceptual questions at first and then start to raise the difficulty and go into more mathematical questions, right? So there we go. We've got multiple choice and difficult questions, sort of ways to extract from your notes and get a little feedback process going on here. And remember how we went through this process. First, we answered the question with no help. Then we looked at the hints, which are the multiple choice. And then we looked at the solution. Okay, next thing we want to do is create an exam cheat sheet. So not only do we have this page of notes, but the problem is you might need, maybe 2 pages, depending if you're doing like, I think in our class we're doing some optics and we're doing some quantum. So I needed 2 pages to be able to do optics notes and quantum notes. But if we're doing one exam, then we want to do only one cheat sheet for just that one exam because it's not going to cover both pages. It's not going to cover everything about optics and quantum. It's only going to cover a small portion of it. So you're going to pull out the necessary equations from the 1 page of notes or 2 pages of notes, whatever. You're going to pull out an even smaller little subsection of those notes. So some equations, some applications, maybe some terms or whatever. And so that's going to be the exam cheat sheet. Once you've finished your exam cheat sheet, you're going to want to make copies of it. So, yeah, basically that's the idea. So, you want to be doing reps. All right, this guy right here in the gym, he's doing reps. So he is getting stronger. He's building those muscles by lifting weights. And you don't just do this weight one time. It's not like you go to the gym and you just do it once and you're like, okay. I'm done with my gym. I'm just gonna do one rep. I'm just do my one problem. Or even better, you say like you have like 10 different problems you're supposed to solve for physics, right? So let's say you do your problems one time each. You say, oh yeah, I finished all my problems. It's kind of like saying, okay, I did one push-up, one sit-up, one squat, you know, one uh one lift. I don't know. So you want to do reps. So if you do one problem, do the problem again and again and again. Find ways to do the problem multiple times. And that's why we were doing the question without help. Then we did it again with the options, and then we did it again with the solution. We might even go and do it again if we want to make a video of this. So you want to get reps in to the problems that you're solving. And yeah, so the most important takeaway from this entire thing, if you pass by a music class, you're going to hear the whole class practicing. You hear that each person in the class is playing their instrument, and it's kind of like this whole orchestra going on. But if you pass by, like, for a team practice, right, in sports, you could see the whole team is training out there on the field. They're either doing like drills during football, they're doing their weird little drills. Maybe they're like doing running around different cones and stuff. Maybe they're passing the ball back and forth. They're scrimmaging on the field together doing drills and stuff, and they're practicing. That's what you see when you go to a sports practice. Remember the orchestra when you're playing music. Remember the sports team when you're playing sports. Now go to a physics class and you're going to hear one teacher talking and everybody else looking around the room with their, maybe they're taking some notes. Maybe they're playing poker on their computer while the teacher's just lecturing. That is a physics class, a classic physics classroom. I've seen it several times, you know, uh, most of the time when the teacher's just lecturing, we're not engaged. It's almost as the scientists don't really see the difference here. They don't really understand how we have like athletes and musicians, and then science. It's all the same. Everything is exactly the same. You practice it the same way every single time. All right. So just like watching sports games doesn't make you a better sports player, you can't just watch the game and get good. It doesn't help you. It gives you motivation to play more sports. Listening to music doesn't make you a great musician. It gives you some ideas. Okay, attending lectures, listening to me talk, listening to professors doesn't make you a great physicist, but you can ask questions. And with that, I should actually take a look and see if anybody has asked a question here. Doesn't look like it. But anyway, so reading textbooks and reading publications and stuff, this doesn't make you a great physicist. You might be able to take some notes. So there's a very, very small impact by going to classes, by reading textbooks. Very small. The true way, the only way to become a great physicist, mathematician, is to solve problems yourself over and over and over again. It's like playing the songs on your instrument, okay? And so that's why math equals music. It's the exact same thing. Here you have a piece of music. So if you haven't heard it before, it's going to be really hard to be able to play it. Okay, and think about how many times you might have to actually hear it before you can even remember the piece of music without looking at the notes. You might have to hear it like, I don't know, dozens of times. Think about how many times you have to practice it to play the song before you can play it without looking at the music. But you probably have to play it more like hundreds of times to remember the whole thing. So now you've done so much practice for this piece of song. Obviously, this is just a few notes, so you could probably do this in like 10 seconds. But if it was like a huge piece of music, it would be much more difficult. But I want you to think about math being equal to music in the sense that problems are songs. And if you want to be able to learn your song, you want to be able to learn your problem, you have to drill it over and over again. Okay, so what happens if you get stuck? And you have a question that's just too hard. You don't really know how to solve it. You don't know what to do. I don't know why we have all of them at once, so we're just going to start with the first one. If you get stuck, the first thing to do is to write down definitions and related terms. So, just start brainstorming stuff. You have an idea, just write it down. related term, write it down. Some related stuff, because you don't know anything and you're completely stuck at a question. It's like, I don't know, how do you calculate the Dirac delta function that's on the order of the conformal field theory in anti-de Sitter space? Man, I don't know. You can start writing some definitions now. You can write, well, anti-de Sitter space is a hyperbolic space. You can start writing, well, the CFT is just the quantum field theory, the Dirac delta function. Maybe I just know that function. You start writing some related terms now. Next, you want to identify variables and constants and what is conserved. So variables, I don't know, maybe a position on the border is a variable. Constant might be gravitational acceleration. What is conserved? Um, probably, probably phase shifts. I don't know. Those kinds of things. So now I start to think about what's the variable in the situation, what's the constant, what is being conserved. The next thing, if you're stuck, is to try to approximate equations. So, you might not remember the equation, so you're just gonna have to write down what you think it is, something approximate. It's close to it, it's not exactly right. Oh well. Check the units, maybe if you remember what the units are, you might be able to plug in and get a little bit closer. Check some limits. Maybe that's a way to sort of get a little bit closer. So the key is to just write down a guess. Just take a guess at what the equation could possibly be and maybe try to adjust it with some units or limits. And then maybe start making some substitutions. So you know that x equals vt or whatever. Go ahead and plug that into your equation. See how it changes things. Rewrite things in another way using square roots or squareds or ln or exponentials. Manipulate it by multiplying it by certain numbers or something, by dividing it or something. So you're doing these different types of things. You don't really know what the answer is, so you're just kind of playing around here. Another thing to do is to maybe draw images, make diagrams, make graphs, see what kind of information you could pull out of that, kind of relationships or lines you might be able to come up with. Um, and if you set two things equal, this is one of my favorite things to do, just randomly set two things equal to each other and find the scaling factor and just maybe work backwards, work forwards and backwards to try to sort of like smoothen out the kinks in like the math or something. There's like somewhere that you missed a little hole there. And another thing is to just look for the questions that all the questions that you've answered so far, all the other answers that you've given, maybe there's some answers in those questions already. Or maybe there's unnecessary info that's given in this question that is throwing you off track. Another thing is to just erase everything and start over and think without writing. A lot of times, you just think really carefully without writing anything down. Cluttering the paper is just going to clutter your thoughts. So clear everything and just think. Okay, and write down one thing and then think very hard. Try to solve it in your head and then write down the solution that you've figured out in your head. So you're not writing a bunch of junk on the paper. Another thing, it's possible that the question was worded in such a way that made it so confusing, but it's actually a really simple answer that maybe you even already done it before in like a homework assignment, and it's just asking the question in such a complicated way. It seems different, but it's actually the same question. So just like um, try to see if it's a simple answer. Maybe it's just a confusing question with a simple answer. See if there's missed some kind of assumption that the question is assuming. And finally, and this is another good one I like to do, is to answer a simplified version of the problem. So, like, maybe they're adding some extra, fudge factor or some kind of perturbation in there that, you haven't really figured out how to work with perturbations yet. So, just solve the original version without the perturbation, give that as your answer, and then maybe from there you can try to adjust the answer a little bit, or even just try to approximate the answer. So, these are some of the tricks that you can use. Um, if you're stuck. Of course, the second best place to be practicing this process is at home with these practice questions. It's the second best place to be practicing. The best place to be practicing is in class with worksheets and with groups and with classmates. That's the best way to be practicing. The problem is most teachers will not do this because they think their job is to lecture rather than to train students. Okay, now, I don't know any sports coach who makes lectures and give homework assignments, or at least makes that a big part of the process. I know sports coaches who like to give drills and who like to make their teams practice during practice time or scrimmage together with the team, but I don't know any sports coach who's just going to lecture to their students and then give them homework assignments to go do at home by themselves. It makes no sense. It's like people are deliberately crippling us physicists by not practicing in the effective ways that sports teams practice in, athletes do it, musicians do it, but scientists, for some reason, we assume that the students are just going to go do that by themselves, that they don't really need the team to be able to like work together, solve problems together. Some teachers do that. Language teachers tend to do that. I had a really good language teacher once who just, had us do this constantly. We kept switching groups, drills, doing this, that in practice because we were doing language. But if we're doing math, it seems like all of a sudden we lose the connection here. We kind of go off into our own little quiet world and we don't even like work together anymore. It's very, very strange to me. Of course, a lot of guitar teachers love to show off to their students, right? During their lessons, they just play, play, play. And then they're like, oh, yeah, wasn't that great? Like, go home and practice it. And they don't actually have their students practice in class. Guitar teachers do it all the time. But just realize that if anybody actually does this, like they might be really good at what they do, but they just don't really have any idea how to get results for the people watching or interacting, which means you kind of have to do it yourself. Um, and I mean, obviously watching this video, there's not a lot of interactivity with this video, so it's not as effective as just solving problems. Okay, maybe it's about 20% effectiveness. Anyway, if you want to learn about more about physical science, I have the Archives of Physical Science available. It's hopefully we're looking at this. This is an amazing book here. So we got the Archives of Physical Science. Uh, this is this is cool. This is my website right here. It's physicsformulasheet.com. You can go ahead and check it out. It's the free download. We got a nuclear physics chapter upgrade, a quantum physics course upgrade, a study pack upgrade. It's a complete guide. This is going to save you time and it's a good, efficient review. But anyway, thank you so much for watching this interesting video on exam preps, and I hope you all do a little bit better in your exams next time. Have fun.